Okay, good afternoon, class. Today we're looking at the introduction to algebra. And yesterday we looked at simplification of expressions, we looked at multiplication. And then we started off addition and subtraction, not some. Okay, so the bell rang. So what we're going to do is we're going to start off again from the beginning. Sorry? No, we can just carry on. Okay, so today we're looking at addition and subtraction. In this lesson we're looking at addition and subtraction on page 18. However, this is the examples for exercise 4 on page 18 as well. The question says a plus a. So what is a plus a? Is 2a. Again, don't write it on the side across like that. You write it below this and you skip a line. And you got number 2. Okay? You all okay with this? Okay, so a plus a is 2a. Remember, yesterday we said, if you multiplying, so a times a would have been a squared. So you added the exponents here. When you're multiplying, and bases are the same, you add the exponents. However, when we're adding, we add the coefficients. That would have been 1 plus 1 is 2a. And also when you're adding and subtracting, the variables stay the same. And they have to be what? They have to be like terms when we add the variables, like if we add terms. Right, you guys understand? Okay. Let's look at number 2. Number 2 we have 4x plus 2x. So are they like terms? Are the variables the same? Yes. So 4 plus 2 is 6. So it becomes 6. Again, when adding and subtracting, the variables stay the same. Okay. Any confusion? Look at number 3. Number 3, we got 2a plus a plus 3a. So write that down. 2a plus a plus 3a. Why did you guys open some windows? It's cold, but it smells as well. Doesn't it smell nice? Don't you like it to be fresh smell or something? Right, so 2a plus 3a. Here's taken 5a. You all agree with that? Who says 5a? You're wrong. 6a. You look at it like this. Not an O man, it's an A. If you got 2, say A is apples, okay? So we have 2 apples plus another apple is going to give you 3 apples. Not so. And 3 apples plus 3 apples is 6 apples. You understand? So in other words, 2a plus 3a is going to give you 6a.
My apologies for the interruption. This is Siwe Hidleri. Can you please report to the office? This is Siwe in grade 9. Can you please report to the office?
Okay, so people remember when we wrote down in the previous lesson, we said if there's an x, what's the coefficient of x? 1. What's the denominator here? 1, and the exponent is also 1. Can you see that, people? So, if you're looking at this a, and there's no number, there should be a 1 there. We're going to write that 1 so often that we leave it out. We tend to leave it out. Okay? So that if it's nothing is written there, we know it's a 1. Okay? Is there anybody else that's confused? You guys understand, eh? Let's look at the next one. Number 4. Write this one down and do it quickly. You've got 2x plus 3x plus y. 2x plus 3x plus 1. Okay, behind taken, what is your answer, Michael? Five x squared. When you're adding and subtracting, the variables stay the same. So it must be 5x, yes? You're right, and you're on the right track. It's 5x and is it 5xy or 5x plus y? 5x plus y. Why 5x plus y? Because 2x and 3x is what we call like terms. Can you see that? So when we're adding, we can only add the like terms together. Remember in our previous lesson we said we used the example of the forks and no? Did I use it with you guys? The forks in the drawer and what? No? So if x were forks and y is a knife. Okay? So we have 2 forks plus 3 forks and a knife. So you add it together, what do we have? We have 5 forks and a knife. Why? Because they are different. Can you see that? It's still utensils, but it's still cutlery, you know what you call it. But it's only that those two are the same. So 2 plus 3 is 5. So it's 5x plus. Can I put that together? Can I add it? Can it become one term? No. Why? Because they are different. They are unlike. That you guys understand? So make a note there. 2x and 3x are like terms, and then 5x and y are unlike terms. Okay. So when we're adding and subtracting, we can only add and subtract like terms. Okay? You guys understand? Look at number 5. Write that down, you answer it. 10x minus 3x. Yes?
Is it negative and a positive or subtraction?
It's a subtraction. We're not at that point now, negative and positive. And the integers. We're not there yet. Have you done that last year already?
Yes.
Yes, then you're confused about it, that's why. Okay, so what is 10x minus 3x? 7. You all agree with that? Remember, when we're adding and subtracting, the variables stay the same. They have to be like terms, not some. And what makes terms like? Variables, yes? Has to be exactly the same. And the exponents has to be the same. No? Okay. Let's look at number 6. We've got 5p squared minus 3p squared. Are they like terms? Both these p squares. Okay. Yes?
Say for example, it was 5 squared p minus 3p squared
5p squared 5 squared p
minus
minus 3p squared. Is that the question? But what is 5 squared? So 25p minus 3p squared. Are these like or unlike? Unlike. Why? Because the variable, the exponents must also be the same. So can I subtract that? No. So that's your answer. Okay. Five p squared minus 3p squared, they are like terms?
2p squared.
2p squared. Remember, when we're adding and subtracting, the variables stay there? Look at the next one. Look at this, an easy one. Okay, then again, all the sums are easy. Huh? Number 7. You got 8ab minus ab. What's your answer? Are they like terms? Yes. So what's 8ab minus ab? 7ab. What's the coefficient of ab? 1. So in other words, 7 minus 1 is? 8 minus 1 is? 7. Adding and subtracting the variables stay there? Number 8. We've got 2x plus x plus y plus 4y. Write that one down. Shazad, what are you busy with? Huh? What's that? Glue? The fix. What did we say about the fix? Don't use the fix. You're wasting your time. Just put a line through it. Don't color it in, just put a line through it. That's it. People, 2x plus y plus 4y. Are they all like terms? No. So what we do is we say, okay, 2x and x are like. Not so. So you see me now grouping the like terms. And y plus 4y is also like terms. You see the grouping is different. Okay? So what is 2x plus x? 3x. Not so. What is y plus 4y? So it's plus. Are they like or unlike? So I can't add. Sorry? Oh, you want? Right. So here we are told from the examples above, we see that only like terms may be added or subtracted. So make a note there. From the examples above, we see that only like terms can be added or subtracted. Okay. So what we're going to do is I'm going to give you a chance now to do exercise 4. And then afterwards I'm going to do a few examples of exercise 5. But exercise 5 doesn't have a set examples there. So I'm going to use my own examples for exercise 5, which is on page 19. But I would like you guys to do now exercise 4 on page 18. Okay, I'm going to pause the video at this point. Okay, so at this point, you guys did the odd numbers. So there was some concern. So I'm just going to highlight a couple of things before we go on to examples for exercise 5. Okay. So number 1, that was simple. Everybody got that right? 2x plus 3x is 5x. Let's look at number 3. This is where the problem starts. remember that 6x is a like term to 3x. So what do? I group. I'm going to make this a bit bigger. Enlarge it a bit more. Okay. So 6x and x is like term. So I group them. Right. Then 1 and 3. So what's 6x plus x? 7x. Remember, if there's nothing, there's a 1 in front. What is 1 plus 3? 4. So it's plus 4. Okay. What is the confusion here? I know some of you add everything together and got 11x. No? You can't because it's unlike terms. Yes, Michael.
So I just have a question.
Yes,
What
ask.
if, like these like two numbers and they are
Give me the numbers. Sorry?
You've got number 9.
I'm still getting to number 9. I'm still getting to number. I'm asking what's the problem here? No problem. Anybody else with number 3? They're still confused. Right, let's look at number 5. What is like terms here? 5x and negative 2x. 7 and 1. You see now some people is thinking that that negative belongs to the 1. No, it doesn't. The negative belongs to the term. Can you see that? So in other words, what is 5x minus 2x? 3x. Okay, so that's 3x. And what is 7 plus 1? Can you see there? 7 plus 1, which is? Is positive. Is this like or unlike? Okay. You all okay with that?
Yes.
Right? Go up a bit. What do you say number? The next one is number 7 you're supposed to have done, huh? Number 7 and then number 9. So what is like terms to 5a? A. And to A? That as well. B and 2b are like terms. You can only add and subtract like terms. Okay. So what is 5a plus a? 6. And 6a plus a? 7. What is b plus 2b? So it's going to be plus 3. Okay. So what you are saying about number 9?
So I was just wondering.
Wondering, yes.
Some of the terms that are like they have different like
Variables.
then they like the one is plus and that one is minus.
That means to say that this minus belong to 3p. That minus only belong to 3 and that minus only belong to p. Makes sense? So 6p is a like term to which one? Negative 3p. 4 is a like term to which one? Negative 3. 5q is a like term to? Negative 3. Makes sense? So what is 6p minus 3p? 3p. What is 4 minus 3? 1. Plus 1, eh? And what is 5q minus q? 4q. Positive 4. Okay? You guys understand? Yes. Alright? Mark the side quickly. The idea is never to have done this on this video, but there was confusion, major confusion. Okay? Right, number 11. 10x minus x are like terms, and 5xy and 3 minus 3xy are like terms. Okay. Even though there is an x, but the whole variable is in the same. There's a y here. Can you see that, people? So what is 10x minus x? 9x. What is 5xy minus 3xy? Look at number 30. 5x cubed is a like term to negative 2x cubed. Is it a like term to 2x squared? No. This is squared and that is cubed. The indices or the exponents must be the same. Then we have 5 is a like term to 2. So in other words, that one is standing on its own. Okay. So what is 5x cubed minus 2x cubed? You see how am I using this negative? 5x cubed minus 2x cubed. 3x cubed. What is 5 plus 2? 7. And then that one's on its own, so I just write it down. If you had to be a minus, I would have just said negative 2x squared. Yes, Michael?
So will be wrong if I say plus.
No, that's absolutely correct. 3x cubed plus 2x squared plus 7. Or 7 plus 2x squared plus 3x cubed. It's all the same. Okay? That was your question, eh? Okay. Is there any other confusion here? Let's look at number 15. 3x squared is a like term to x squared. 4xy is a like term to 2xy. And this one is standing sole alone. Not so. So, what is 3x squared plus x squared? 3x squared plus x squared. 4x squared. What is 4xy plus 2xy? 6xy. And then plus 2x. Or 2x plus 4x squared plus 6xy. It's all the same. Okay. Yes, Michael?
So I have a question about
Ask.
number
You don't have to say you have a question.
about number 17.
Number 17. Yes.
At in 4yx, will that be a like term to the other?
Where were you for the lesson? Did we explain this already? Is xy the same as yx? Okay, if I didn't explain, look at it this way. Say you got xy. Say x is 2 and y is 3. Then what will this read? 2 times 3, which is 6. You see that? Now what if you got yx? So what is y? 3 times 2, which is? So that means to say, they make a note there, that xy is the same, is equal to y. Okay, that's the same. But look at it this way. What if we add, what if I add x squared 1? Then what would that now read? 2 squared times 3, not so. What's 2 squared? And 4 times 3 is 12. What if you add yx squared? So that would be 3 times 2 squared. What is 2 squared? 4. 3 times 4 is? Which means to say what? X squared, y squared, y is equal to yx squared. You see the variables are exactly the same. Right. You just spice up your life with well, otherwise your life will be boring. Okay, erase the 4, no? So it's 2x times 3, which is 12. No? What if you add y squared x? Notice here the square is on the x and here the square is on the 1. So this would be what? 3 squared times 2. What's 3 squared? 9, and 9 times 2 is 18. So what can we conclude? Therefore, xy is never equal to y squared x. Okay. So if this is jumbled around, no problem, but the exponent must be on the right variable. Yes, Michael?
So sir, does that mean for number 17, they're all like terms?
There we go, they are all like this. Okay. So let's do number 17 quickly. So they're all like terms. So what's 12xy minus 5xy? 7xy. 7xy plus 4yx? 11xy. And why do you think I didn't write it yx? Because we want it in alphabetical. Right, you guys understand? For homework, I would like you guys to redo the whole exercise. Okay? You're going to do the odd and even. In this case, you got the answers to all the odd numbers. You can mark it on your own. And then the even numbers we'll do in our next lesson. Is that okay? Now coming back to exercise 5, which is on page 19. As I said, there's no examples for this exercise in the textbook. So I'm going to just draw up a few of my own. Okay. So I've noticed over the years as I do this exercise with learners, they actually are confused when it comes to this as well. Okay. People, algebra, you need a lot of practice. Okay, it's something that it's something new to you. It's a lot of rules, so you must practice it a lot. Okay. So let's look at example 1. These are my own examples. If you have got 4a times 3 minus 2a times 2. Write that sum down. You've got 2a multiplied by 3 minus 2a multiplied by 2. How many terms are there? 2 terms. What separates terms? Addition and subtraction. 2 terms also known as what? Binomial. Alright. So this, yes?
Must we work it out to say how many terms there are?
No, you can see from here. What separates terms? Plus and minus sign. So there's 1, 2 terms. You don't have to work it to know how many terms there are. You can see it from the
So we find the answer. That's what
yes, you
we're
must.
asking.
Oh, you must calculate.
Yes.
Yes. Yes. Yes. Yes. Sorry, man, I misunderstood. Right, what's your answer? 8a. Who says 8a? Correct. How do you get 8a? According to Bodmas, multiplication first. 4a times 3? 12a. Minus 2a times 2? 4a. 12a minus 4a? 8a. You guys understand? Let's do the next example. Example 2. Do that one quickly. Here's example 3 and do that. Sorry? 10x, 10 times x, minus 2 times x, minus 1 times x. Okay, what's your answer to example 2? 7a. You all agree with that? You got at the back. What's your answer? Yes. You got? 13. So you actually worked out this first. Let's say you got 13a. Not so. But why is she wrong? You must apply Bodmas. Not so. So multiplication first of 16a minus 3a times 3? 9a. So what is 16a minus 9a? 17a. 7a. So. Yes? 8. People, number 3 quickly before we leave. Example 3. What must be done first? Multiplication. What is 10 times x? What's 2 times x?
2x.
What's negative? What's 1 times x?
1x.
1x. Or just x. So what is 10x minus 2x?
8x.
8x. And 8x minus x? With that, you should be able to do exercise 5. 12 more. All 10 sums, okay? You will enjoy the rest of your day and you'll eat tomorrow. Good afternoon, class. The full lesson can be found in the description box below.